As there will be the first maybe 3 minutes, 5 minutes will be assistance over yesterday's stuff. I'm sorry again. This is difficult to switch to e-learning, so bear with me. I'm sorry I made a mistake. You had a couple of homework problems where you're asked to find if radians measures are coterminal. And so there's a couple ways we can do this, okay? So for example, I have two radian measures. The first, and maybe the easiest, depends on who you are, is to convert both to degrees. So you have pi over 2, and we need to convert that to degrees. So if you recall, we multiplied by 180 over pi. Oh look, pi's cancel out. That simplifies to 90 degrees. So we know 90 degrees. Well, let's convert 5 pi over 2 to degrees as well. So we have 5 pi over 2 times by pi over 180. Oh look, pi and pi cancel out. 2 goes into 180 90 times. So then you just have to do 5 times 90, which hopefully we can do in our heads, right? Sorry, joking fit. You get 450 degrees. So can we add 360 degrees to 90 to get 450? We definitely can, which means they are coterminal. So that's a yes. One way to do it is to convert both of them to degrees. That works totally fine. So give yourself a second to get this copied down, otherwise I'm going to race to work right now. The other way we can do this is by the same concept. Coterminal angles, you add 360 or you make one full revolution around, right? Well, if I have, I'm going to draw a nice little unit circle. Yeah, it's terrible. If you have an angle right here, this is your arc length, so in radians this would be the measure you get. If you make a full revolution around, whoop, this angle would, or that would also be the same angle. However, you add a whole revolution of radians, which is 2 pi, right? So we could add 2 pi to pi over 2 and see if that works. Now, it is basically like adding fractions. I hope we can add fractions. You can write any number as a fraction over 1. And to add fractions, you need a common denominator. So, I need this 1 right here to be a 2. So I'm going to multiply both the top and the bottom by 2 so that I don't change the problem at all. So you have pi over 2 plus 4 pi over 2. Well, you could think of this as adding any variable. If you have 1 pi and you add 4 pi's to it, you have 5 pi, and then over 2. Remember, in fractions, when you add, you don't change the denominator. So 5 pi over 2, that's what happens if you add a full revolution. Oh, look. That's what we got there. So they are coterminal. So for your homework, if you have problems like this, you can either convert everything to degrees and figure that out, or you can just add 2 pi or subtract 2 pi, get common denominators, and get it that way too. So there's multiple options we can do. I'm not picky on what we use right now. So if you're more comfortable with degrees, that's fine. I mean, either way, I think adding 2 pi wasn't difficult. So this is going to be the help for that homework. I'm sorry I left that off. That's my fault. I'll try to get this posted the same day. But the rest of this video is going to be over 6.2, okay? And so, or sorry, 6.1 day 2. So if you give me a second to close out of this and open up the correct file. 222. Okay, and so this is the bell ringer for Thursday. So this is going to be Thursday's lesson that you need to watch. So if you want to pause and give yourself a moment to try to complete these, go for it. Otherwise, I'm going to get started. So from radian to degrees, so we have, need my pen out, 3.4, and we need to multiply it by 180 over pi. Now this is a case where, again, pi's don't cancel out. So if you remember in the lesson, I would just prefer a decimal because you'll get some weird number over pi degrees, and that doesn't mean a whole lot, I don't think, to me. So we'll do 3.4 times 180. You get 612 over pi. So yeah, we have 612 over pi degrees. Yeah. Let's divide by pi, and so we get a better idea of what this angle measure is going to be. So I'm going to go to thousandths. If you notice in my lessons, I do that quite a bit. Again, not picky. Don't worry about it. So you have 194.806 degrees. Okay, so that's a little better picture than 612 over pi. Well, 3,600 degrees from degree to radian. So again, 3,600 times by pi over 180. Well, 3,600 divided by 180 will get you 20. And then that pi is left over. So 20 pi would be your answer there. Which makes sense because 1 full revolution is 2 pi, right? And 1 full revolution in degrees is 360 degrees. So if you multiply that by 10, you have 3,600 degrees. So same way with 2 pi times 10, you get 20 pi. So this is another example of what we just talked about. Again, I apologize. So we have 3 pi over 5 and 42 pi over 5. We need to make sure that these are coterminal or determine if they are. So I'm going to do it both ways. First way we can do is just add 2 pi. Now we might have to keep adding 2 pi, which is fine. If you add 2 pi, again we need common denominator. So I'm going to multiply this by 5 and this by 5. So you have 3 pi over 5 plus 10 pi over 5. So if you add those, you get 13 pi over 5. So that's not anywhere close to 42 pi over 5, so we need to keep going. Well, the shortcut is 2 pi written as a fraction over 5 is just 10 pi over 5. So you can just keep adding 10 pi over 5. Oh look, that'd be 23 pi over 5. And if you notice, we're adding 10 every time. So the next one would be 33 pi over 5. And next one would be 43 pi over 5. If that makes sense. Oh look, 43 pi over 5. Is that the same as 42 pi over 5? It definitely is not. So these angles are not coterminal. Another way you could do it is convert it to degrees. So pause if you need to keep writing this down. I'm going to erase this and do this in degrees then. So 3 pi over 5. Let's convert to degrees. So times by 180 over pi. Pi's cancel. How many times 5 going to 180? Hopefully we know. You get 36, right? So 5, 36. 3 times 36 gets you, oh, I typed in wrong, 108 degrees. Now let's do 42 pi over 5 times by pi over 180. Pi's cancel. This is 36. So 42 times 36 gets you 1,512 degrees. And so you can just keep adding 360 to 180. So if you add 360 to 180 once, you get 468 degrees. All right, let's add it again. You get 828 degrees. Okay, we're still not there yet. Okay, again you get 1,188 degrees. Let's go again. You get 150 or 1,548 degrees, which obviously does not match our 1,512 degrees. So again, this way we also get a big no, they're not coterminal. Okay? So, jumping ahead. Today is actually pretty self-explanatory, especially if you got yesterday's stuff. It's basically just formulas you plug values into. There are going to be story problems, but they're very basic, so I think we'll be okay. So I'll find the arc length of a circular arc. So we're going to be able to find arc length, and then we're going to be able to find the area of a circular sector. So if we cut out a piece of pizza out of pizza, we can find the area of that. Okay? So, arc length of a circular sector. S. We can ignore the proof for now. The important thing that we need right here, arc length in radians, is S equals R theta, where S equals the length of the arc and R equals the radius. So, for instance, I'll give you a second to get that written down. Feel free to pause. If I ask you to find the arc length of this angle, let's say it's 120 degrees. 120 degrees angle, they want you to find the arc length that's created. Well, we also need to know R. So let's say R is, 5, okay? So S equals, R is 5, and then times theta. Now, we haven't referenced theta. Basically, it's just the x for angles, okay? I don't know if you've ever run across that. It's just a variable for angles. So we're going to see that a lot. Sometimes you'll still see x. It just means variable for angles, okay? And we pronounce it theta, okay? So we have 120 degree angles. However, the quantifier for this formula is that your theta or your angle measure has to be in radians. So we can't plug in 120 degrees. It has to be in radians, okay? So we need to do 120 degrees, and then we need to convert it to radians. So that's pi over 180. So we can simplify that down, right? 12 and 18, what goes into both? Hopefully we know. I almost said 4, that's embarrassing. 3 goes into both, right? So 3 goes into 12 4 times. We have pi on top. What am I doing? I'm sorry, guys. What am I doing? 6 goes into both. So 6 goes into 12 twice. We have pi. And 6 goes into 18 3 times. So you get 2 pi over 3. So you have to multiply 5 by that angle measure in radians, which is 2 pi over 3. So you would just multiply it out. 5 times 2 times pi divided by 3. And we get S is about 10.472. Now, usually they're going to give you units. I didn't in this example, so I'm just going to say units. So, finding arc length is pretty self-explanatory. It's just plugging in. The only issue we had last quarter was making sure that you convert to radians first. So this is very important. You can't plug in 120 degrees. You have to plug in the equivalent in radians. Okay? So oppositely, if you do a little algebra, you get that the angle measure equals the arc length divided by R. So sometimes maybe they'll give you the arc length and the radius, and they want you to find the angle. So that's the formula you can use for that. So these two formulas right here and right here are what we need. Those will be beneficial to us. I'll give you a second to write that down. So let's change that because I don't want to have that twice. Let's do 150. Why not? So we want to find the arc length given that this angle measure is 150 and the radius is 4.5, okay? So this is 4.5, this is 4.5. And so arc length, they're asking us to find the arc in between these two rays, okay? So arc length is S. So S equals R times theta. Well, R is 4.5. And now, hopefully, we know we don't plug in 150. You have to convert into radians first. So 150 times pi over 180. Zeros cancel out. You have 15 over 18. This time 3 goes into both. Okay, we got 5 pi over 6. So you have to multiply 4.5 times 5 pi over 6. So if we do that real quick, 4.5 times 5 times pi, all divided by 6, gets you about 11.781. Now we have to look at units. They do tell us that the radius was 4.5 inches, which means our units are going to be inches. And that would be your answer. Okay? So that's easy enough stuff. We don't need to worry about that too much. There will be some of these on your homework. Now finding the area of a circular sector, it's kind of similar. It's just another formula to memorize. If you have an angle, like I have here, now I just called it the generic theta, which is the variable we use for angles, sorry, brain fart. So we have this angle here, and the area is what's in between the rays and in between the end of the circle, okay? So it's what I shaded in green, that's what you want to find. Obviously, there are some uses to this, for instance, circular gardens, circular anything. We can find area using this because areas of circle are not as easy as areas of a square, rectangle, or even triangle. But the area of a sector area equals 1/2 times the radius squared times theta. So again, r is radius, and theta is the angle in radians. Again, radians, we need to be in radians, and that's important that we do so. So, let's go on to an example. We're first asked to find the area of sector and then the arc length. All right, well, this 30 degrees they're telling you is the angle measure, and we know that the radius is 10 meters. Okay, so area of a sector is 1/2 times r squared times theta. So the only thing we need to fill out is your r squared, which is 10. So you have 10 squared times theta. Well, we don't plug in 30. That's a big no-no. So we have to convert 30 off to the side into radians. So you're going to do pi over 180. Well, this one is nice. 30 goes into both. 30 goes into 30 once. 30 goes into 180 6 times. So you get pi over 6. Okay? And so we have to multiply by pi over 6. And all you have to do is multiply it out. Remember, order of operations, you do have to square to 10 first. You can't do 1/2 times 10 and then square it. So 10 squared is 100 times 1/2. You get 50 times pi and then divide by 6. So your area of that sector right here, of this right here, all this, I get is about 26.180. Now units, they said meters. And that's that. Easy enough, right? So the area of that sector is 26.18 meters. Now let's find the arc length. We have everything we need already, right? S equals r times theta. Well, we know that r is 10. And we know that theta in radians is pi over 6. So we can just do 10 times pi divided by 6. So your arc length is about 5.236. And again, that's meters. If you notice, I made a mistake up above. If we're talking about area, it's not just units, it's units squared. So there should be that squared there. So if we're talking about the arc length, it's just the measurement. It's not area, so you'll say just that unit. But if it's area, it's always units squared, okay, if you remember. Again, I'm not a real stickler on that, but it is important to note. So sometimes they like to make you think about things. So sometimes they'll give you the problem in words, they won't give you a picture. Now I'm a visual person, so I definitely need my picture. So I'm going to draw a picture whenever they just give me a sentence describing the problem. So, a circle has a radius of 4 degrees, okay, easy enough, or 4 centimeters, sorry. And the central angle has an arc length of 6 centimeters, okay, so we have no idea what the angle is, but we know that the arc length is 6 centimeters. Okay, so that problem was worded weird. Basically, they gave you two things, the radius and the arc length. So we need to find that measure. And they want us to do it in radians and degrees. Easy enough. So, we already have arc length. So let's use this idea. So S equals 6, right? Oh, not C, 6. And R equals 4. Well, how do we solve for theta? You just divide by 4, right? So you get, divide by 4, you get 3 over 2 or 1.5. So theta equals 1.5. Now if you remember, theta was always in radians. So that's radians. Well, let's convert that to degrees, okay? So to convert 2 degrees, you have 1.5 times by, well, do you guys remember, if we're converting 2 degrees, we definitely need the pi on bottom, because usually we're canceling out pi, and on top. So you do 1.5 times 180 divided by pi. You get, and the angle measure is about 85.944. And that would be degrees then. Okay? So sorry that problem was worded weirdly. They just try to set up the picture for you using words, and I like to draw it to see what they're looking for, but they want us to find the measure of that central angle. Okay? So let's do another one. If the area of a sector of a circle is 12 inches squared, given the central angle is 30 degrees, find the measure of the radius. Okay? So I'm going to draw another picture. They tell us first that our angle is 30 degrees, and we know that the area is 12 inches squared. Okay, and so we're going to have to use that area formula to find this. So we know the area is 12, so let's plug in 12 for A, equals 1/2. Now R stands for radius. That's what we want to know. So we need R squared by itself. We want to get that by itself. And then we can plug in theta. Remember, it has to be in radians, so it cannot be in degrees. So we have to convert 30 to radians. So we got pi over 180, which simplifies to pi over 6. We've done that one in this lesson already. So it's just times by pi over 6. Well, now we need to solve. So we need to get rid of this 1/2 and this pi over 6. Well, we'll just multiply by reciprocal instead of 1/2 multiplied by 2, right, to get rid of that. So you get 24 equals R squared times pi over 6. Now again, to solve to get rid of a fraction, you multiply by reciprocal, so I'm going to multiply by 6 over pi to both sides. And so we have 6 times 24, which will get you 144 over pi equals R squared, because these cancel out. So, last but not least, you need to find R. So hopefully we know to solve for r here, you would have to take square root. Now, I'm going to address this question before it already happens. What about plus or minus? Well, we can't get a negative value for the radius, right? Radius of our circle is going to be positive, so we're just going to focus on the positive value. So I would type in 144 divided by pi, you get 45.836623661, and then take the square root of that. And I get that r is about 6.77. However, we're given the units, so it'd be inches. And look there. So we used the formula to kind of work backwards this time. We can do that. You just have to think about what they're asking you, okay? So here is going to be the homework for today. Now again, I will let you guys know if this homework assignment changes. I would never add more, but I could subtract some off. Just try your best. Again, there's many great online resources. I'm sure you guys have heard of Khan Academy. Use each other. Use me. I'm here for you guys. That's my job. So if you have questions, please ask. Also, homework is just for you guys to practice. So what I would recommend is that you try them all on your own, and then you compare your answers with the answer key, okay? That's what I would do. That's what I recommend. And then you see, oh, hey, that's where I went wrong, okay? It really gets where to copy down the answers. I mean, it's a free homework grade, but in the long run, if we come back to school, I'm not going to reteach all this necessarily word for word. So it's expected that you do learn this stuff, okay? But again, I'm here to help you, so if there's questions, please, please, please ask me, okay? And make sure you're staying up to date on filling out my Google Forms for attendance. Please make sure you're turning in assignments on time. And I'll see you guys tomorrow on the next video.